Students, I am going to discuss about measurement of pressure using manometers. If you want to measure pressure of a fluid which is flowing in this pipeline, before allowing the fluid to flow in the pipeline, we have to drill a hole and we have to insert a glass tube which is open on both its ends. So that arrangement is shown here. The fluid which is flowing in the pipeline will rise on the glass tube, and the level rise is measured with respect to the center of the pipeline, and pressure is given as P is equal to rho g gauge. Here the pressure thus measured is a gauge pressure. So this use of piezometer for the measurement of pressure is very simple and very easy to use, but it has got limitations. Gas pressure cannot be measured using this piezometer. The gas column cannot be visible on the glass tube. If the fluid which is flowing in the pipeline is under vacuum pressure, this arrangement cannot be used. So outside air will enter into the system if the vacuum pressure is prevailing inside the pipeline. So these are the two limitations of using a piezometer for the measurement of pressure. To overcome these two limitations, we are using a U-tube manometer. So a U-tube manometer is a glass tube which is bent in the shape of a U. Either we can use an upright U-tube manometer or inverted U-tube manometer. We have to drill a hole on the side wall of the pipeline, and we have to fit a nipple. Then the U-tube manometer is connected with the nipple using a flexible hose as shown in this figure. Now the U-tube manometer is ready for measurement of the fluid which is flowing in the pipeline. When the fluid is flowing in the pipeline, the level of fluid rises on the right limb of the manometer, and the pressure is measured as P equal to rho g gauge. If the fluid which is flowing in the pipeline is under vacuum pressure, then the level will decrease. So it is taken as minus h, and the P is given by minus rho g gauge. As I already told you, the pressure measured this way is gauge pressures. Still, use of U-tube manometer doesn't cancel all the limitations of the piezometer. When the gas is flowing in the pipeline, still the U-tube manometer cannot give a reading, visible reading. So for overcoming these drawbacks, we are using a different fluid in the manometer that is called manometric fluid. So we have to fill a manometric fluid in the manometer. Then one end of the manometer is attached to the pipeline which is carrying fluid whose pressure is to be measured. So the true drawback has been overcome with the use of a different fluid in the manometer. So this arrangement can be used for measuring the pressure of fluid like water as well as gases also. The second drawback is about the measurement of the vacuum pressure. So this arrangement is equally good to find the pressure of fluid which is flowing under vacuum pressure. One end of the manometer is open to atmosphere, and the other end of the manometer is connected to the pipeline. which is carrying fluid whose pressure is to be measured. The left vertical tube of the manometer is called left limb. This is called right limb. The right limb is open to atmosphere, and the fluid which is filled in the manometer is called manometric fluid, which is having a density of rho m. The fluid which is flowing in the pipeline will act up to this level. So that fluid is having a density of rho. So whenever we want to calculate the pressure using a U-tube manometer, we have to identify a datum level. This is the datum level for this example. How to identify a proper datum level? So this datum level is identified such a way that the connecting side of the manometer is having same fluid below the datum level. If I choose this as the datum level, the connecting side will have two different fluid. So that is not the right datum level. So once you identify the datum level properly, then we can start making calculation for measurement of the pressure of fluid. So on the datum level, pressure is equal both on the left limb and right limb. So PL is the pressure at the datum level on the left limb. PR is the pressure at the datum level on the right limb of the manometer. PA is the pressure of the fluid which we need to measure. So at the datum level, PL equal to PR. Okay. So the pressure will be equal at the datum level on both the limb. Only then the reading will be stable. Suppose you imagine PL is more than PR. What will happen? There will be a continuous rise of fluid on the right limb. Suppose if PR is more than PL, then there will be a continuous depression of the level on the right limb. So PL has to be equal to PR in order to get a stable reading. Okay. Now using this technique, we measure the pressure PA. First we will find the pressure PL. So pressure PL is equal to pressure PA plus pressure due to H1 meter of fluid which is flowing in the pipeline. So PA is the pressure. Normally we want to measure the pressure at the center of the pipeline. So PA is the pressure at the center of the pipeline. So the same PA will be acting on horizontal plane. So the PA will be same even at the entry to the manometer. So if this is the PA, then the same PA will be acting here also. So using this, we find the PL is equal to PA plus pressure due to H1 column of flowing fluid. So PA plus rho g H1. Then we will find PR. So PR is the pressure at datum level on the right limb. It is due to H column of manometric fluid. So PR is given by rho m GH. So equating 1 and 2, we get PA plus rho GH1 is equal to rho m GH. So from this, PA is found as rho m GH minus rho GH1. So let us solve example problem. Water is flowing in the pipeline whose pressure we want to measure, and mercury is used as a manometric fluid. So what is the pressure prevailing at the center of the pipeline? So we have to take a datum level, then we have to find the PL and the PR. So PL is given by PA plus pressure due to 50 mm of water column. So that's given by rho GH. So density of water is 1000, G is 9.81 and H is 0.05. meter. So PA plus 490.5 is the pressure acting at the datum level on the left limb. Similarly, we will find PR. So PR is due to 100 mm of mercury column. So rho mgh we have to use. So PR is given by 13,600 is the density of the mercury into 9.81 into 100 mm converted into meter as 0.1. So equating these two, we find the PA as 12.85 kilopascal. Now we are going to discuss about inclined U-tube manometer. So when the pressure of the fluid flowing in the pipeline is of little magnitude, the upright U-tube manometer cannot give a comfortable reading. So the reading shown by the upright U-tube manometer will be very little if the pressure of the fluid flowing in the pipeline is less. So in that case, we can make use of an inclined U-tube manometer where one end of the manometer is inclined at a particular angle theta. So we will measure the rise of the fluid, manometric fluid on the inclined tube, okay, along a scale which is fitted parallel to the inclined tube. So we will solve the problem. So inclined U-tube manometer is employed to measure the pressure of water. Okay. So these are the reading. The inclination is 30 degree and mercury is the manometric fluid and the water is flowing in the pipeline, and the level is measured as 4 centimeter on the right limb along the inclined plane. So when we want to use this 4 centimeter reading, we have to convert this 4 centimeter into vertical height before we substitute in the equation, because pressure varies only with respect to vertical height only. So as usual, let us identify a datum level. On the datum level, PL equal to PR. So PL is given by PA plus pressure due to 0.25 meter of water column. So that is PA plus 2452.5. Then on the right side, we measure the mercury column on an inclined plane as 4 centimeter. This 4 centimeter has to be converted into vertical height before you substitute in this formula or OMGH. So this 4 centimeter is converted into 2 centimeter. So using this Pythagoras theorem, the angle is 30 degree and this is 4 centimeter. The vertical height is 4 sin 30 into 2 centimeter. So that is substituted in this formula. PR equal to rho mgh, h is 0.02 meter. So now equating 1 and 2, we get the PA as 215.82 Newton per meter square or 215.82 Pascal. Now let us discuss about another type of U-tube manometer. This is called well type U-tube manometer. So which is shown on the right side. So what is the use of well type U-tube manometer? This is also called as single column U-tube manometer. So first we will discuss about the ordinary U-tube manometer, which is having uniform diameter throughout its length. So in case of a U-tube manometer, we have to fix 2 scales for the measurement of the level in both the limbs. Similarly, let us say that we are fixing 2 scales, one for the left limb and one for the right limb. So before the manometer is attached to the pipeline, which is carrying a fluid whose pressure we want to measure, the manometric fluid level will be same on both the limbs as shown here. the level is 4 centimeter. On left limb, the level is 4 centimeter on the right limb. When this is attached to a pipeline, which is carrying a fluid, then the level will differ in both the limb depending upon the pressure prevailing inside the pipeline. So here in this example shows the level has come down to 2 centimeter from the 4 centimeter, initial level of 4 centimeter. So how much it has decreased? 2 centimeter. The same 2 centimeter will rise on the right limb. So initial level was 4 centimeter before it is attached. Now it has come to 6 centimeter. So the level decrease on the left limb is equal to level rise on the right limb, because the U-tube manometer is having uniform diameter throughout its length. Okay. So now how to find the H value? So right side is 6 centimeter, left side is 2 centimeter. So 6 minus 2, 4 centimeter. So this 4 centimeter we are using in the calculation for finding the pressure. What happens in case of a well type U-tube manometer? So this is called well, which is having a larger diameter compared to the other end of the U-tube manometer. The level will decrease a little on the left limb because of its larger diameter. The level will rise to a more extent on the right limb. Now we have to find the H value as 7 minus 3.8 is equal to 3.2 centimeter. But what we do is we neglect taking a reading on the left limb. We take the rise of the manometric fluid only on the right limb for calculation. So before this manometer is attached to the pipeline to measure the pressure, initially the level is at 0 on both the limb. 0. So we fix the scale, the level is against 0 mark. Once it is attached to the pipeline to measure the pressure, there will be a small decrease in the level, assuming that the pressure is more than atmospheric in the pipeline. So there will be a small decrease delta H on the left limb, and there will be a larger rise on the right limb. Okay, let us say for this example, the level is at against 3 centimeter on the right limb. Now this delta H is normally neglected when you use a well type U-tube manometer. We neglect the level decrease on the left limb. We measure the level rise on the right limb only, because we have fixed the scale against the initial level on the manometer. So what is the advantage of using well type U-tube manometer is we get the direct reading of H from the scale. So we don't have to find the level in the left limb, find the level in the right limb, then subtract one with the other. So those calculations we are avoiding when use a well type U-tube manometer for the measurement of pressure. So the level which is shown on the right limb is directly taken from the scale. So the level is against 3. So we take H as equal to 3 centimeter. So there is a small error in neglecting the delta H on the left column. So this error can be reduced by using a very large diameter of well and and a convenient diameter of tube. So the A is the area of cross section of the well and small a is the area of cross section of the tube. So if you want to reduce the error, the ratio A by A should be larger.